Test, test, test. right. Good evening to all of my viewers. I can see there are a few people that are in the audience, which is awesome. Thank you guys for tuning in. Welcome to this year's Regents Review live stream. We are going to be going through the June 2023 Algebra 1 Regents exam. Thank you for the 100 reacts I see over there in chat. Much appreciated. We are going to go through the entire test from start to finish, multiple choice and short response, part 1, 2, 3, and 4. If you have a physical copy of it that I gave out in class today, you can follow along on that. Or if you didn't manage to get a copy of that, I did post a digital copy of the Regents on Google Classroom. So if you want to just follow along, or if you want to do the questions while I do them, absolutely. If at any point you have a question, Tadulo, thank you for your chat message. If you have a question at any point about any question, I'll try to give a little bit of buffer time between questions while we work on them. Feel free to ask. That's kind of the whole point that we're here for. If you aren't sure about something, then I'd be more than happy to go over it again. So, if there are no holdups, if everyone is ready to go, then we are going to get started. So, just to clarify what we have, we've got our test here. This is what you're going to get tomorrow. You will be provided with a pencil. You will be provided with a pen, so you do not need to bring anything to write with. We will provide you with it. You don't have to worry about that. In addition, gel pens are not allowed, so regular pens like this are what you want. You're also going to have a ruler that is given to you for any graphs that you might need to make, and you will have your graphing calculator. So we're going to be definitely using that plenty while we go through this Regents. Any opportunity you have to use the calculator, you absolutely should. It's a great tool. Before we get started, I'll give a couple seconds to answer. Are there any questions in chat before we begin? Okay. Doesn't seem like there are any. Oh, wait. I'm waiting. You're biking home. I mean, we are going to start. You probably won't miss too much. How long do you expect to be until you're home? A minute? I can do that. I can do a minute. So we're going to wait about a minute or two, and then we will begin, everybody. Let's go to. We'll be okay. I guess in the meantime, we can start with just writing our name and stuff like that, which seems like a very trivial piece of this, but you want to make sure. We want to write almost everything on the Regents in pen. Your multiple choice answers must be bubbled in pen. Your short response answers must be in pen. If they are not, the answers will not be accepted. We will literally have to ignore them while grading. So please keep that in mind. So let's start with writing our name. I'm going to write my full name out here. That is Christopher D. Donato. And for your high school, your school name, you're going to write Liberty High School. Just to go over the front of this test quick, this is going to be read to you tomorrow, but we're just going to go over it really quickly. There are 4 parts in the test. Part 1 is multiple choice. Parts 2, 3, and 4 are your short response questions. Everything is in here. You will receive a separate sheet for your multiple choice answers to bubble those in. You'll see those tomorrow. In addition, you do not get scrap paper, so any work that you have to show must be shown in here. Again, multiple choice, you do not even have to show work if you don't want to, so, worth considering. This is important. When you get to the end of your test, you will have to sign a statement basically saying that you didn't cheat or that, you didn't get any information from places you shouldn't have. If you don't sign that sheet, and we will remind you, but if you don't sign it, again, we can't give you a grade. So please make sure you sign that. You'll get your graphing calculator, you'll get a ruler, and that's that. All right, I'm going to open this up. We are going to get started. And again, after any question, if you have any questions at all, please just ask in the chat. Let me move this down a little bit. Okay. Let's get right to it. So our first question, question 1 on part 1. There are 24 questions in this part. The expression 9m squared, or 9m to the power of 2, minus 100 is equivalent to one of these 4 choices. So generally, anytime you have an expression that has something squared minus something else, and it's asking you to find an equivalent expression, which, remember, equivalent just means equal, that means we are factoring. You left your packet at school. I did post it in Google Classroom, so you can follow along with this test, even if you don't have it on paper. So this is what's called a difference of 2 squares, or rather difference of perfect squares. All you need to do for a difference of perfect squares problem is identify what multiplied by itself gives you 9m squared and what multiplied by itself gives you 100. For 9m squared, well, we know there's going to have to be a 3 in there, and since m is squared, it's just m, 3m times 3m. So we know that our answer is going to have 3m in the first space, which all of our answer choices do, so that doesn't give us a whole lot. 100, on the other hand, well, if we're not sure what the square root of 100 is and we need to check, we have calculators for a reason. So, hopefully the screen is visible. All right, I'm going to have to play around with the angles here. We go into our calculator. Oh, man. And we want to take the square root of 100. We do that. We get 10. So that means that we just have to find the answer, and difference with perfect squares, there's a plus and a minus, which only leaves us with one answer choice. That's going to be choice 1, because it's got the 3m, it's got the 10, and it has the plus and the minus, which is what difference of perfect squares is. So the answer is choice 1. If there are no specific questions about that one, we're going to go right on to question 2. Which expression represents an irrational number? So if we think back to what kinds of numbers are irrational, one of the main standout things that tells us a number is irrational is if you take the square root, I'm just going to kind of exaggerate here, of a non-perfect square. Once you see one of those, if you see a number under a square root that is not a perfect square, that's going to be an irrational number. So we can check each of our answer choices. Choice 1, square root of 16 plus the square root of 1. 16 is a perfect square. 1 is a perfect square. So that's not our answer. Choice 2, 25 is a perfect square. 4 is a perfect square. So once again, that is also not the correct answer. 36 is a perfect square, but 7 is not a perfect square. And you can always check if something is a perfect square by just taking the square root of it. That's not the right button. Square root, you hit Control, oops, and then you hit that button. If we take, why does that keep happening? There we go. Square root of 7. We get a long decimal. Sorry, it's a little blurry. If you take a square root and you get a decimal, then that number is not a perfect square. So that's our answer. That's going to be our irrational number. Any questions for number 2? Okay. Seems like we're good. So let's keep moving. All right, number 3. Which linear equation represents a line that passes through the point -3, -8? So there are a few ways to solve this problem. I think one of the easiest ways to do this is to plug this point into the equations until you get a true statement. Because remember, when you have a point like this, a number comma another number, that represents x and y. And since all of our equations have x and y in them, we can just replace the x with -3, and we can replace the y with -8. And if we get a true statement, then that's the answer. So let's start with choice 1 here. Y equals 2x minus 2. Go to the calculator here and turn the brightness down a little bit. Hopefully that makes it a little easier to see. There we go. That's definitely better. So I'm just going to type in -8 equals 2, and then instead of x, I'm going to put in parentheses -3, close parentheses, minus 2. So all we did here was take the equation that was in choice 1, and we plugged in our x and our y values. We hit enter, and it says true. So since we plugged it in and it said true, that turns out to be the answer. We just got lucky that it happened to be choice 1. That's not always going to happen. If, for example, we do that again, but instead of -2, we do -8, like in choice 2, we're going to get false. So that's how you know that is not the answer. Okay, give a second for questions on that one. Okay, seems like we're good. Also, I'm looking over. It looks like we got 13 people in the audience. Love to see it. That's better than last year's turnout of 1. Oh, Tadula, wait. So you just plug it in. Pretty much, yeah. Since we've got an x value and we've got a y value, since all of these equations are just in terms of x and y, just replace x with the x value, replace y with the y value, and see if you get a true statement. That's all you got to do. All right. We are going to go for number 4. The expression 5x squared minus x plus 4 minus 3 times x squared minus x minus 2 is equivalent to one of these choices. Now, you can use the calculator for this, as we demonstrated in class today. However, this is a question where it's probably in your best interests, both, in simplicity and in time, to just do this out. So let's simplify. Anytime you have a number multiplied outside parentheses like this, we want to use the distributive property. So we're going to distribute this -3 to all 3 of those terms. So I'm just going to write my equals over here. So this comes out to, now we don't even need to write the first part in parentheses anymore, 5x squared minus x plus 4. We multiply -3 by x squared, so we get minus 3x squared. -3 times -x, a negative times a negative is a positive, so that comes out to positive 3x. And then -3 times -2, again, negative times a negative is a positive, so we get plus 6. And now we just combine our like terms. So our like terms in this case, we've got 5x squared and minus 3x squared, since they both have x squared. 5 minus 3 is 2, so we end up with 2x squared. Now, common mistake is when you're doing something like this, you end up adding the exponents together. Do not do that. The exponent should stay the same. So that means we can actually just eliminate choices 3 and 4. And then we continue. minus x is like terms with plus 3x because they're just x. So negative x plus 3. Remember, there's an invisible 1 there, so negative 1 plus 3 is 2. So we get plus 2x. And right off the bat, we can already choose our answer. Because even though we haven't finished yet, if we do, these are our like terms here. 4 plus 6 is 10. But we already had the 2x. Positive 2x. So we know it has to be choice 2. How did we get 2x squared? The 2x squared came from 5x squared minus 3x squared. We just combined our like terms. 5 minus 3 is 2. Hopefully that answers that question. Okay. If there are no other questions on number 4, we are going to move right on to number 5. The 24th term of a sequence, or of the sequence, negative 5, negative, if it's in minus, we subtract yes. Negative 5, negative 11, negative 17, negative 23, and that just goes on and on and on. We want to find the 24th number in that sequence. Now, what you don't want to do, you do not want to try to just continue it manually. Don't go, oh, negative 17, negative 23, the next one would be negative 29. You would be here way too long if you tried to do it that way, and there's a high chance that you'd make a mistake. What we want to do here is we want to use our arithmetic sequences formula. That formula looks like this. AN equals A1 plus D times N minus 1. This formula is given to you on your reference sheets, so don't be afraid to use it. It is given to you. You don't have to memorize this. What this allows us to do is take any sequence and find any term in it. So all we have to identify is A1, which is just the first term, and D, which is the common difference. A1 in this case, it's just the first term, negative 5. And D is whatever it's changing by. So negative 5 to negative 11 to negative 17. Since we're going down by 6, the difference, the common difference, D, is negative 6. So we just plug all this into our formula. N is going to be 24 because we're looking for the 24th term. So A, 24, equals negative 5. And we're going to subtract, since D is negative, minus 6 times, 24. Almost forgot to replace N. Minus 1. You can now just take that entire expression and plug that into the calculator if you want, or you can simplify it manually. That's also an option. So we're going to do negative 5 minus 6, parentheses 24 minus 1, and we get negative 143. So that's our answer. So anytime you see the word, I forgot to write it here. Anytime you see the word sequence, you want to look for this formula. Again, it is on your reference sheet. Use it. Any questions on how we got that answer on question 5? You got 139. Trying to think. Did you do times 24 minus 1? Or, yeah, I'm saying, did you forget to put the minus 1 or maybe not put it in the parentheses? Because that can cause an issue like that. Yep. It's a common issue. Just be careful with parentheses and things like that. All right. We're going to move on to question 6. Flipping the page. Which term is D? D is found by checking what you're changing by. So since we went from negative 5 to negative 11, technically if you do negative 11 minus negative 5, basically take the second term and subtract the first one, that difference, negative 6, gives you D. It's a good question. All right. On to question 6. When completing the square, oh boy, our favorite thing. Completing the square for x squared minus 18x plus 77 equals 0, which equation is a correct step in this process? So it's not asking you to completely do the process of completing the square. You just need to figure out which of these would show up. So the best way to figure that out is probably to just start doing the process. So anytime we complete the square, we want to start by getting our constant term on the other side of the equation. So here we're going to subtract 77 on both sides, which this cancels out, which leaves us with x squared minus 18x equals negative 77. Now when you're completing the square, the number you care the most about is b. So looking at this equation here, our b is going to be negative 18. We also need b over 2, which is just b divided by 2, which is negative 9. And finally, we need b over 2 squared, which negative 9 squared is going to be 81. And that b over 2 squared you have to add to both sides. So we're going to add 81 to both sides. Now you're going to see after we do this, that's actually all we need to do. We don't need to do the rest of the process. X squared minus 18x plus 81 equals negative 77 plus 81 is actually just 4. And only one of these options has a 4 on the right side of the equation, so that has to be our answer. Choice 1. X minus 9 squared equals 4. And if we did continue the process, yes, this would come out to x minus 9 squared equals 4. But that 4 was all we needed to know for sure that that was our answer. Completing the square is a pretty annoying process, but if you can remember b over 2 squared, you'll be in good shape. Anything I can answer on question 6? Okay. We are going to go ahead and move on then. For number 7, which function will have the greatest value when x is greater than 1? So we got a bunch of different functions here. We want to figure out which one is greater when x is greater than 1. And probably the simplest way to do that would be to pick some value of x that is larger than 1 and just plug it into all of these functions. So what better number that's greater than 1 to use than 2? Let's use x equals 2 and just plug it into each of those. So we'll start with choice 1, g of x. So that is 2 times 5 to the power of x. Oops, let me turn that light off. So we can just type 2, parentheses, 5, to the power of, and the value we're plugging in is 2. And we get 50. So we can just mark that and do the rest of them. The next one is 2x plus 5. So let's do 2 times 2 plus 5. And we get 9. So we know that's not going to be the right answer. An alternate way to do this would be to do like we did in class today and type on the calculator x. And if you hit Control and this button next to 9, you can assign a variable to it. We'll just say x is equal to 2. And then the rest of them, like choice 3, 2x squared plus 5, we can literally type 2x squared plus 5, and it'll do it for us. We got 13. So that's not the answer either. And finally, choice 4, 2x cubed plus 5. We're going to do the same thing, 2x to the power of 3 plus 5. We get 21. So the biggest one is 50, which means choice 1 is going to be our answer. So all that one was picking a value that fits the interval it gave. In this case, x is greater than 1, and just plugging it in. Anything I can clarify on that question? Okay. If at any point you do need to go back to a question, you can let me know and I'd be more than happy to go over it again. But for now, we are going to go to question 8. I'm going to try to refocus this, see if this... That'll have to do. That's a little better. All right, question 8. Mike uses the equation b equals 1,300 times 2.65 to the power of x to determine the growth of bacteria in a laboratory setting. The exponent represents one of these things. So remember, the exponent, whenever we're dealing with an exponent, it's a power. It's one of these little numbers in the top right corner. That means we're multiplying this number by itself this many times. So we need to figure out what this x represents. So Mike here, he's trying to figure out how this bacteria is growing. Generally, when you have an exponential growth formula, which is what this is, this number here basically tells us how many times it's grown. So sometimes that's in seconds or years or days, or sometimes there's no specific time attached to it at all. But in general, that has to do with how much time has passed. The total number is just the whole expression. The percent at which they're growing, that's going to be our growth rate, which is the 2.65 in this case. The initial amount of bacteria is what goes on the outside. That's 1,300 in this case. So the number of time periods is going to be what our exponent represents. If there's no questions on that one, give it a second. We can move on to number 9. Okay. Question 9. A company ships an average of 30,000 items each week. The approximate number of items shipped each minute is calculated using the conversion, one of these awful looking answers. So we did a question very similar to this in class together when we were going over past Regences. One thing to note, the 30,000, we don't care. That has nothing to do with how we're going to find our answer. What we care about are the units. So we need to think about, what are we actually trying to figure out? Well, the number of items shipped each minute. So what we want is items over minutes. So looking at our answer choices, we just need to figure out which one cancels out enough. So here's what I mean by cancels out. We look for what units are on the top and also on the bottom. And if they don't just leave items over minutes, then it's not the answer we want. So for example, choice 1, we have items on the top, which is what we want. No items on the bottom, so it doesn't cancel out. 7 days, no days on the bottom, so nothing cancels out. Minutes, none of those on the bottom. Days, none of those on the bottom. So this is definitely not the right answer. Nothing cancels out. We don't get items per minute. We get items, days, minutes, days over weeks squared, hours squared, which is weird. So that's not our answer. Choice 2, let's try the same thing again. Items, none on the bottom. Week, there is one of those, so we can cancel out week. Day, we've got days on both the top and the bottom. Hours, we've got that. And minutes, we just have that on the bottom. So we just have items over minutes left. So that's our answer. If we look at the other answer choices, we can also see that, yeah, some cancellation happens. Like here, we have days and days. And we have hours and hours. But this doesn't work. There's still week on top. There's minutes and items on the bottom. That's not what we want. And the bottom choice, weeks cancel out. Whoops. days cancel out, and hours cancel out. But this has minutes over items. That's minutes per item. That's not what we're looking for. We're looking for items per minute. So choice 4 is not correct. Any questions on how we got through number 9? Those questions look scarier than they actually are, but it's all just about the units. You look for items each minute or per minute or something like that. Per is another key word that can give that away. All right. If there are no further questions for number 9, we're going to turn the page and we're going to go on to number 10. Also, I'm going to say this now. When we get through the multiple choice section, which is the first 24 questions, we are going to take a quick break. We'll say probably about a 10-minute break, just in case if you do want to watch the whole thing, if you need to go do anything, that's fine. So I'll put a message up when we get there. Okay. A function is graphed below. A possible equation for this function is one of these. So, couple different approaches you can take here. One thing we care about is the zeros of our function. And if you can find the zeros of a function, then it's pretty easy to figure out the function itself, actually. So let's look at where this function crosses the x-axis, because that can tell us a lot. We can see here that it crosses the x-axis at x equals -3. And since it crosses at -3, we have to flip that to find the factor. So that actually means that x plus 3 has to be somewhere in our answer. Over here, it doesn't really cross, but it touches the x-axis at x equals 2, which, by the same logic, means that a factor is going to be x minus 2. Now, based on just those two, we can already eliminate choice 1, because that's x plus 2 and x minus 3, which is the opposite. And we can also eliminate choice 4, because where did this 12 come from? 12 is not a zero of this function. That doesn't work. So now we just have to choose between choice 2 and choice 3. Now there's a couple ways to kind of make that distinction. One way is to see that at -3, it goes straight through. It doesn't stop, it doesn't kind of bounce off the axis, it just goes right through it. So x plus 3, that term is just going to be, or rather that factor, is just going to be by itself. We're more or less picking between x minus 2 and x minus 2 squared. Now, anytime you see a factor like this squared, it looks like this. It bounces off the axis. It doesn't actually go right through it. It's going to bounce off. Another way is that a quadratic, which just means, x squared, is going to look like a parabola. There's 3 x's here technically, since this is squared. So it's not going to be a parabola, which means our answer choice has to be choice 3, because otherwise, if it was choice 2, this would be a normal parabola. Another thing, anytime you're identifying a graph, your calculator can do a lot of work for you. So let's do a quick demonstration. Get that out of the way. If we go into make a graph, either in a new document or a new page, we can input the functions and see if they work. So let's try choice 2. That is x minus 2. Oops, I forgot the parentheses. X minus 2, parentheses, x plus 3. And if we look at the graph of that, it looks nothing like the graph on the picture, so we know that's not the answer. You also could have done that right from the start and not worried about all the factors, but it is good to be able to identify a graph based on that kind of thing. Any questions on our graphing problem, number 10? Okay. Let's keep on moving. Question 11. Also, by the way, if I move on before you have a chance to ask a question, you still can. Like, just ask the question and I will go back. If g of x equals negative x squared minus x plus 5, then g of negative 4 is equal to which of these choices? So, if you wanted to do this manually, we'll do this really quickly and then I'll show you the calculator way. All you have to do is replace x with negative 4. So negative, parentheses, negative 4 squared, even sometimes you have two negatives like that, it happens, minus negative 4 plus 5. We've already got a guess, 2, let's find out. If we simplify this, negative 4 squared, this makes negative 16, minus negative 4, remember negative and a negative turns to a positive. So negative 16 plus 4 is negative 12, which plus 5 is negative 7. So yes, choice 2 is correct. Very good. Now, if you wanted to do that in the calculator, you could have typed it in exactly as we had on the paper there. Or, alternatively, move this over, you could also go back to the calculator and define g of x to be a function. I don't know why this isn't. There we go. So if I type g of x, and then we hit Control and the button next to 9 to actually define it as something, we can type negative x squared minus x plus 5. And that'll define the function for us. And if we now type g of negative 4, it'll give us negative 7. So those are two ways to get the answer, both correct, for the same problem. Give a second in case anyone has any questions on that. Okay, let's go on to question 12. And yes, I am going to read every question from start to finish. I recommend you do the same while taking the test tomorrow. Read the questions carefully. A movie theater's popcorn box is a rectangular prism with a base that measures 6 inches by 4 inches and has a height of 8 inches. To create a larger box, both the length and the width will be increased by x inches. The height will remain the same. Which function represents the volume, v of x, of the larger box? So there's a lot of information here. But what we can break that down into is the volume formula. And the volume formula, again, is given to you on your reference sheet. If it ever starts talking about something like volume or formulas like that that you don't immediately recognize, check the reference sheet. It is there for a reason. The formula for volume is length, L, times width, W, times height, H. Now, according to this problem, the height, or rather the length, was 6, width was 4, and the height was 8. But if they're trying to increase both the length and the width by x inches, whatever x is, we just need to add x here and add x here. So instead of 6 now, it's going to be 6 plus x. And instead of 4, it's going to be 4 plus x. And 8, the height, they said nothing about changing the height. Actually, they did say it remains the same. So that's still just going to be 8. And then we just check our answer choices. Choice 1, 8 plus x. Nope, that's not right. Choice 2, 6 plus x, 4 plus x, and 8, all multiplied together, just like our original formula. So that's going to be our answer. It's definitely not going to be 3 or 4, because those add the length, width, and height together, and that is definitely not the volume formula. So Number 2 is it. Anything I can clarify on that one? Okay. We are going to turn the page and move on to question 13. The expression 300 times 4 to the power of x plus 3 is equivalent to one of these choices. This is another one that can be a little overwhelming when you first see it because this looks weird. We haven't seen something like this in a while, but the key property that you want to remember for this is with exponents. If I do, let's say I have x to the power of a times x to the power of b. That is the same thing as x to the power of a plus b. So since we have something plus something, 4 to the x plus 3, write that over here. Based on our rule over here, this should be the same thing as 4 to the x times 4 to the 3. And wouldn't you know it, choice 1 has exactly that. So since this is equal to this is equal to this. So it's got to be choice 1. That's just kind of going back to our exponent rules. That was Unit 6. That was a long time ago. Give a second for questions on that one. Okay, let's keep going. Ashley only has 7 quarters and some dimes in her purse. She needs at least $3 to pay for lunch. Which inequality could be used to determine the number of dimes, D, she needs in her purse to be able to pay for lunch? All right. So we need to pay attention to the information that's given to us and a lot of the terms that are given to us. Key term you want to look for here, at least. When you see the term at least, that should immediately translate to greater than or equal to. Because if you need at least an amount of money, then it has to be either equal to that or more than that. So immediately we can eliminate choices 3 and 4 because those have less than or equal to. So it's just down to choices 1 and 2. Now this is tricky because the part that allows us to solve this doesn't actually appear anywhere in the problem, but we need to think about what each of these inequalities represents. And really, the only difference between them is choice 1 has D and choice 2 has 0.10 D. So we need to think, well, if D is the number of dimes, and this whole thing represents a total of some sort, we would have to multiply the number of dimes by 0.10, because a dime is worth 10 cents. And the 1.75, well, that just came from 7 quarters, so 7 times 0.25 equals 1.75. We didn't even need to figure that out. So choice 2 is what we're going to go with, because that accounts for the value of a dime. And that's it. All right, let's tackle number 15. The formula for the area of a trapezoid is A equals 1/2 times B1 plus B2 times H. The height, H, of the trapezoid may be expressed as one of these. So this is a pretty straightforward equation solving problem. Is it a bit annoying? Sure. But we know how to solve equations. We use our inverse operations. What we can do to start, since H is what we want by itself, is let's get rid of this 1/2 first. Anytime you have a number outside parentheses and you're trying to solve an equation, you want to deal with that. And fractions have a unique way we can get rid of them. If we have 1/2, we can cancel that out by multiplying by 2 on both sides. So on the left side of the equation, we end up with 2a And on the right side, this 2 and this 2 cancel out. So we just end up with b1 plus b2 times h. And we actually just have one step left. Since we want h by itself, and it's being multiplied by b1 plus b2, we can just divide by b1 plus b2 on both sides. So we end up with 2a over b1 plus b2 equals h. And so we've solved the problem. We got h by itself. Choice 4 matches what we got in our solution. So choice 4 is the answer. It's all about reverse, doing the reverse of something, looking at what you want to get rid of in part of an equation and just doing the opposite. If there are no further questions, we're going to move on to question 16. The function f of x equals the absolute value of x is multiplied by k to create the new function g of x equals k absolute value of x. Which statement is true about the graphs of f of x and g of x if k equals 1/2? So this is going back to our transformations unit, where if I have some function f of x, if I do k times f of x, it's going to stretch it. Let me just draw an arrow. Stretch the graph. Now, this works for any function, so we don't even need to use absolute value necessarily to test this. If we go into the calculator, let's make a graph. Let me put this down. We're going to go ahead and make a new graph. Not geometry, that is not what I meant to hit. There we go. Let's just make up some f of x. We'll do absolute value, just to keep things consistent. You hit the book, it's the first option, abs x. In case you don't remember what absolute value looks like, it looks like this. Then we do tab, and we can just do the fraction 1/2 times absolute value of x. The same thing. And we can see how it compares. So just based on the graph, we can see that it did stretch the graph and it made it wider. So when you multiply by a fraction like that, it does actually make the graph wider, which kind of sounds counterintuitive because you'd think it'd make it smaller. But that isn't how it works. It really is just that it's growing slower. That's a way to think about it. So based just on the graph, we can conclude, that's the one I was looking for, that g of x is wider than f of x. Any questions on that, or any questions on anything from this page? Okay. Doesn't seem like it. So in that case, we're going to go ahead and move on. We're getting pretty close to the end of the multiple choice section here. We're on question 17. This goes up to 24. All right. Some adults were surveyed to find out if they would prefer to buy a sports utility vehicle, SUV, or a sports car. The results of the survey are summarized in the table below. What we want to figure out, of the number of adults that preferred sports cars, approximately what percent were males? So when you see this word of, like of the number of adults that, in this case, preferred sports cars, that's where you're looking. This is all we care about now, is the people that preferred sports cars. We need to figure out what percent of them were males. So if we go over to the side here, there were 38 males that said they preferred the sports car. And of the people that preferred a sports car, there were 84. So 38 over 84. This question about how much time do we have to take the math, Regents? As a baseline, you get 3 hours. You have to spend 2 hours there minimum. You can't leave before that. 3 hours is the regular, but if you get extended time for an accommodation, you can have 4.5 hours if you get 1.5 times. And if you get 2 times time, you can have 6 hours. But most people, you get 3 hours. It's a good question. So, to get our answer here, we can use our calculator. We're just going to go back to the regular calculator section. And I'm just going to do 38 divided by 84. And if you want a decimal answer, which if you're dealing with percentages, you definitely do, hit Control Enter. And we get 0.452 about. Again, this is multiple choice, so you don't really need to think about rounding very much. Sorry. So 0.452. And as a percentage, remember with a percentage, you just move the decimal twice. So this is 45.2%, which is choice 2. So key thing here was just identifying which column we were going to look at, which was the sports car column. We're talking about what percent were males, 38 divided by that total. And there's our percentage. Even if you didn't know to move the decimals, if you saw 0.452 and one of the answer choices is 45.2, you're on the right path. All right. Give a second for questions on that one, and then we'll move on to 18. Okay. The solution to 2x squared equals 72 is... Now, normally, if you had an equation that wanted you to find the solution, I would recommend just using the numerical solve feature on the calculator. However, we've got this pesky squared here, which means we can't really use that feature that way. So this is something that, in my opinion, is much easier solved manually. So we want to use our inverse operations to solve an equation. We're going to divide both sides by 2 because we want to get that out of there. That cancels out. We end up with x squared equals 72 divided by 2 is 36. And if something is squared and you don't want it to be squared anymore, you want to solve it, you take the square root, which leaves us with x equals, and I bothered you guys enough with this when we learned it the first time. Remember, every time we take a square root when solving an equation, your answer must include plus or minus. 36 is a nice perfect square, and that gives us 6, plus or minus 6, because 6 times 6 is 36. Negative 6 times negative 6 is also 36. So choice 4 is our answer. Give a second for questions. Okay, on to question 19. 3 quadratic functions are given below. We've got choice 1, which is given as an equation, function 2, which is given as a table, and function 3, which is given as a graph. Which of these functions have the same vertex? There's a good vocab word. So for a parabola, the vertex is kind of the end of it, the turning point. That's a way to remember it, where it turns around. So let's start with the one that we can actually see. We're going to work backwards here. We're going to go to choice 3. So looking at this parabola, our vertex is right here. So that point, that's 2 to the left, so it's negative 2, comma. And it is 5 up, so negative 2, comma 5. I'm going to write that over here so it's a little easier to see. So we can't really eliminate any answer choices yet because we don't know what the vertex of the other two are yet. But once we figure out one of them, that's going to be helpful. So we're going to look at choice 2. Now, since we can't see this graph, we need to identify where it turns around in a different way. We have -3, 2, 5, 5, 2, -3. So we can see it turned around, but it turned around somewhere in between here because we don't actually see that top value. We don't see that 5, it would be in this case. Now, we can see that the point -2, 5 is on this graph because there's our x and there's our y, but we also have -1, 5, which we don't have here. So since this happens, what essentially happened here is this went up. We've got a point here, and we've got a point here. This is -2, 5, and this is -1, 5. But the actual vertex, we don't know. We could figure it out, but we can tell pretty easily it's not going to be -2, 5. So 2 and 3 do not have the same vertex, which means choice 2 is definitely not the answer. In addition, choice 4 can't be the answer because that says all of them have the same vertex. So now we just need to find the vertex for function 1, x plus 2 squared plus 5. And the easiest way for us to do that is to graph it. I'm sure you guys are tired of me saying just do it in the calculator at this point, but I promise there is a reason. So we've already got some graphs going. Let's just make a new one. And let's type in parentheses x plus 2 squared plus 5. And lucky for us, the vertex is on screen. So if we hit menu, and then we hit 5 for trace, and then we just hit enter, that allows us to move around our graph. And if we go to the vertex, we can see, that it is indeed -2, 5. There's our vertex, and it even says minimum right there. So we now know that this one also has -2, 5. So 1 and 3 are the same, but 2 is not. So that leaves us with choice 3. And that's it. Any questions on this particular question or on this page as a whole? Okay. We are going to turn the page. I'm going to move on to question 20. And once we finish this page, we'll be done with the multiple choice. After we're done with the multiple choice, like I said, we're going to take a 10 to 15 minute break and come back and do the short response questions. All right. So for question 20, the domain of the function f of x equals x. The domain of the function f of x equals x squared plus x minus 12 is one of these intervals. Now, domain. When we're talking about the domain of a function, that means the inputs. Basically, what values are we allowed to plug into this function? Now, that might sound like kind of a weird question, like, well, what do you mean? Why wouldn't we be able to plug something in? Well, if we had a function like, we'll just make one up over here, g of x equals 1 over x, that one's a little different because there is something we can't plug into that function, 0. So, and that's because you can't divide by 0, so we would say that 0 is not in the domain. However, in this question, we're not dividing by anything. There's nothing really, no rules here we can break. So if you can plug any number into this function, then the domain is just going to be from -infinity to infinity. As weird as -infinity sounds, it just means every number. We can put anything into our function, and it's not a problem. Remember, the opposite of domain is range. Range, I'll even write this, range is the outputs of a function. Domain is inputs, range is outputs. Okay, let me keep that down here. For question 21, a bit of a disclaimer on this one. We are still going to do it, but don't worry too much about it. This is asking for something called a recursive formula. Recursive formulas are no longer in the Algebra 1 curriculum, so you're not going to get a question where you have to have an answer that looks like this. That being said, I will still explain shortly how to get the answer here. A recursive formula is just a formula that is based on the previous number. So they're always defined in terms of the first term, a1, and then a formula, which is an plus 1. So 1 and 2 are immediately not the right answer. Anyone from Miss Russell class comment 122? I am not in Miss Russell's class, but if you are coming from Miss Russell's class, welcome. I'm happy to have you here. Now, just trying to figure out the formula here. The first number is 10, of course, because that's where the weekly allowance starts. The question describes this, that what is this? Yeah. The father with his son. The father increases the allowance by doubling it and then subtracting 8, which we're just between these two. It really just comes down to the parentheses difference, but since choice 3, you are, all right, awesome. Choice 3 has us doubling an, which is the original amount, and then subtracting 8, so that would be the answer. As I said, you're not going to see that on the Regents. Recursive formulas are no longer in the curriculum, so don't stress about that. All right, let's do 22. What is the solution to the inequality below? So we've got 4 minus 2/5 x is greater than or equal to 1/3 x plus 15. So you've got two choices here. You can solve this manually by hand using your inverse operations. We'd have to subtract 1/3 x from both sides, subtract 4 from both sides, and try to get x by itself. But that's time consuming. There is actually another way to do this, and of course, you're never going to guess. It's with the calculator. So what we can do is we are going to go into another graph. So let me get this on camera. I'm going to make a new one. We're already up to 5 functions. Look at us. We are not just going to write this as a function. We're actually going to hit delete, which gives us the option to make it a relation. So that allows us to type in anything. So I'm just going to type in what we have there. 4 minus, control divide for a fraction, 2/5 x. That is a greater than or equal to, so we're going to hit control and the equal sign, which brings up this menu. We want to pick the greater than or equal to. Another fraction, 1/3 x plus 15. Now, if you hit enter on this one, you might have a concern initially, like, hey, where's the graph? Well, sometimes it's not visible initially. So if you want to find it, you can either zoom out or you can use that trace function like we used earlier. We hit menu. We hit 5 for trace, and then 1 for graph trace. And it'll find it for us. So we can see here that this is just a vertical line, which is fine. But we can also see it tells us what x value it occurs at, -15. So we already know the answer is either going to be 3 or 4. We just have to decide between less than or equal to or greater than or equal to. But looking at the graph, since it's shaded to the left, not the right, if we go to the left of something on the x-axis, it's less than, left for less than. So it has to be choice 3, because that is x is less than or equal to -15. So even simple problems like that, the graph, just being able to see it and analyze it can give us a lot of information. All right. 2 more, and then we'll take our break. Question 23. Which statement is correct about the polynomial 3x squared plus 5x minus 2? Now, these answer choices, they're mentioning degree, which is something we haven't really talked about in a long time. But remember, for a polynomial, the degree is just the highest power, or the highest exponent, rather. So if we look in here, the highest exponent that we have is 2, which means that this is a second degree polynomial. So choices 1 and 2 are immediately, incorrect, because a third degree polynomial would have something with x to the third. So we just have to decide between 3 and 4. Second degree polynomial with a constant term of 2, or a second degree polynomial with a leading coefficient of 3. So the constant term, that just means whichever term doesn't have an x attached to it. So not this one, not this one, but this one. But our constant isn't 2. It's negative 2. So choice 3 is not correct. So we can confirm that choice 4 is correct. It says it has a leading coefficient of 3. That just means that the number that is attached to the term with the highest power, which is in standard form all the way to the left, is 3. It's the first, the leading coefficient. So the correct answer is choice 4. We okay on that one? 3 hours for the Regents. That's why he's doing this for 3 hours. Yes. I'm not going to force this to be 3 hours long, but if we go for 3 hours, which is what happened last year, then so be it. All right. We're going to do this last multiple choice question, and then, like I said, we're going to take a short break. A store manager is trying to determine if they should continue to sell a particular brand of nails. To model their profit, they use the function P of n, where n is the number of boxes of these nails sold in a day. A reasonable domain for this function would be one of these. So right above this in question 20, we talked about domain. Domain is the inputs of a function. So we need to figure out what makes sense to put into this function. N, that's our input, represents a number of boxes. So we need to think, well, what numbers could that be? It could be 1 box, it could be 2 or 7. So if we go to the real numbers is basically just every number. So I couldn't have, 1.7 boxes. That doesn't make sense. So it's not the real numbers. Integers, remember, integers are basically, I'll write this down because this is important. They just have no decimals and no fractions. And that's the only requirement. Integers can be negative. We can't have negative 7 boxes. That doesn't make sense. Rational numbers are fractions. We can't have 5/7 of a box. It doesn't really make sense. So it's not going to be the rational numbers. So all we're left with is the non-negative integers, which are also known as the natural numbers, or the whole numbers. You might see that. And that has to be our answer, because that makes sense. It can't be negative. It needs to not have a decimal or a fraction. So the non-negative integers is going to be our answer. And that is everything in the multiple choice section of the June 2023 Algebra Regents. This is part 1, questions 1 through 24. Does anybody have any specific questions about what we went through? Any concepts that they want me to go over quick? I'll give a minute for everyone to page through, look for any questions they might want to ask. So give you a minute for that. Okay. Doesn't seem like anyone has any questions right now. So we are going to take a short break. I am going to say let's return at 6:25. So go do whatever you got to do. I will be back here at 6:25, and we will continue with parts 2, 3, and 4 of the Regents. See y'all in a little bit. All right, it is 6:25. We are back. I will give everyone another moment in case you left and you're still on your way back. And then once we do begin, we're going to be starting on the Part 2 questions, once again on the June 2023 Algebra 1 Regents. Before we get started, did anyone have any questions from Part 1 that they wanted me to go over again quickly? I'll give everyone a moment to get situated and ask any questions they might have. If I get all the multiple choice right, but none of the short answer, will you pass the Regents? If you get all of the multiple choice on the Regents correct, yes, you will pass. The curve, the exact number depends year to year. The past couple years, though, it's generally been about 14 out of 24 questions of the multiple choice. If you get 14 of them right, that generally is a pass. It's a borderline, but it's a pass. So, long answer to a short question, yes. If you get all the multiple choice right, you will pass. All right. So, we're going to jump right into 25 here. Remember, each of these questions, they're worth 2 points. This is the same amount of credit as a multiple choice. However, you do need to show work for these. If you do not show work for these, you cannot get full credit. So make sure you read the questions carefully. Do all of your work in pen. It says here, all answers should be written in pen. If you solve this whole problem and you do it correctly, but it is written in pencil, you will get 0 points. So please be careful with that. If you want to do your work in pencil and then write over it in pen, that's fine. All right. Solve the equation algebraically for x. So we've got this big equation here, and we want to figure out what x is. Now, we've done questions like this before, both this and with systems of equations. My recommendation for any solve the equation problem is, as weird as it sounds, find the answer before you do the work. Because then even if your work is wrong, at least your answer can be right and you can get a point. So we're going to go right to our calculator because of course we are. And I'm going to go ahead and jump back to our regular calculator document so that we can access the solve feature. We did this during class today and we're going to do it again. If you hit menu, think of it this way, you start with menu like we do with everything. The algebra regents is what we're taking, so we're going to hit algebra. And there's one equation to solve, so we're going to hit 1 for numerical solve. Now, we type in the entire equation that we're trying to solve. So, negative 2.4, parentheses, x plus 1.4 equals 6.8 x minus 22.68. I accidentally left out the negative or the minus. And then, super important, if you don't do this, it won't work. You have to type comma x, or whatever variable you're solving for. You can use any variable, but x is the one in our equation right now. We hit enter, and we get 2.1. So I'm just going to write right here, x equals 2.1. As long as we show some work, even if that work isn't completely correct, we can get credit for that because we've got the answer. Now, we have to actually show the work. So when we're solving an equation, again, our goal is to get x by itself. So what I would recommend starting with, we've got this negative 2.4 multiplied outside of the parentheses. So anytime we have something multiplied outside parentheses, we want to distribute that. So that's going to be our first step. We end up with negative 2.4x. Negative 2.4 times 1.4, that's not really easy to do by hand, so we'll just do it on the calculator. We get negative 3.36. Keep that there while I write it. And the other side is currently unchanged. Now, we need to start getting our like terms together. We need to start moving the x terms onto the left side and the constant terms onto the right side. So let's start with the constant terms here. Let's add 3.36 to both sides. Since it's minus, we're going to add it to cancel it out. That leaves us with negative 2.4x equals 6.8x. And if we do negative 22, I'm going to go right back to the calculator, negative 22.68 plus 3.36, we get negative 19.32. We're almost there. 2 more steps remaining. Since our x terms need to be together, we're going to subtract 6.8x from both sides. That's going to cancel. Negative 2.4 minus 6.8 gives us negative 9.2x equals negative 19.32. And our final step here, we are going to divide both sides by negative 9.2. That cancels, and we get x equals negative 19.32 divided by negative 9.2, and we get 2.1, exactly what we wrote right at the beginning. Now, as a reminder, for short response questions, I know the temptation is there to circle your answers. Don't do it. Because again, if something here was right and the right answer showed up, but then you did more and you ended up getting something wrong and you circle that wrong answer, the graders will have to take that as the answer, even if the right answer was somewhere else. So just leave the answer here. Make it clear to see. Don't, hide x equals 2.1 in the middle of here, but make it clear, and you don't have to circle it. And that is question 25, our first short response question. I'll give us a moment to ask any questions we have there, and then we will move on to question 26. Okay, seems like we're pretty good. So we are going to move on to 26 on the next page. The function f of x is graphed on the set of axes below. We've got a graph of a function here. Our two tasks are to state the zeros of f of x, and we do have to explain our reasoning. So again, if you just answer the first part but do not explain, you cannot get full credit. So make sure you answer every part of the question and answer it as fully as you can. So the zeros of a function, that's where f of x, where the function itself is equal to 0. Or in other words, it's where y is 0. So y equals 0, that's going to be right along the x-axis. So we just need to figure out what are the x values that make this equal to 0. So right over here, we've got negative 2. Right here, we have 2. And here, we have 3. All we did was identify the places where the graph crossed the x-axis, where it's equal to 0. Didn't really need to do any calculations or any fancy math here. We were just looking at the graph. That's half our answer right there. To explain our reasoning. Think of explain your reasoning as if you simply wanted to just, someone asked you. Imagine you were having a conversation and say, hey, how'd you get that answer? Write what you would have said. Think about explain your answer that way. So we knew these were the zeros because that's where the graph crossed the x-axis. So let's say the graph crosses the x-axis when x is equal to -2, 2, and 3. And since the definition of a zero is it's the same thing as an x-intercept, this is enough of an explanation. Where the graph crosses that axis, those are the zeros. And there's our explanation. So that one actually didn't take too long. I'll leave that up for a second. If anyone wants to write that down, or if they have questions, I'll give you a minute or a few seconds. Okay, doesn't seem to be any questions, so we're going to move right on to question 27. All right. Brianna creates the pattern of blocks below in her art class. So we've got these, number 1, 2, 3, 4. A friend tells her that the number of blocks in the pattern is increasing exponentially. There's a good vocab term right there. We have to decide, is her friend correct? And then regardless of yes or no, we have to explain how we know. So anytime you see a pattern like this where the amount of something changes, first thing you should do is probably count them. Count how many are in each figure. So in figure 1 here, 1, 2, 3, 4, there are 4. In figure 2, 1, 2, 3, 4, 5, 6. Figure 3, 1, 2, 3, 4, 5, 6, 7, 8. And you can probably guess how many are going to be in figure 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that makes our pattern here 4, 6, 8, 10. Now, exponential growth does not look like that. Exponential growth is when you multiply by the same thing over and over. What we have here is a linear pattern. Linear is addition. We are adding something over and over. So since this is a linear pattern, not an exponential one, is her friend correct? No. That's half our answer. Now we have to explain how we know. And we're going to do that just using those definitions that we just talked about. That if you add the same thing over and over, it's linear. If you multiply by the same thing over and over, it's exponential. So our explanation can be as simple as she adds 2 every time. Now that might not seem like much of an explanation. It might just seem like we're just pointing out what happened. But again, by the definition, linear relationships and patterns are addition. Us saying that she adds 2 every time is us pretty much saying, well, this must be linear, not exponential. So your explanations don't always need to be super in-depth. This is enough to get full credit on this question. So once again, I'm going to give you guys a couple seconds to write that down. And if you have any questions or want me to explain anything, I will do that. Okay. Doesn't look like we have any questions right now. So we are going to move on to question 28. All right, we've got a data set. The data set, I'm not going to read all those numbers, represents the number of books purchased by 9 book club members in a year. Our task is to construct a box plot for these data on the number line below. So this is back to statistics. This was the last unit we did before we started reviewing for the Regents, which means we're doing statistics. You know what that's going to involve? The calculator. So got a lot of documents open right now, and we are not done. We're going to make another one. We're going to hit Control-Doc to make a new document. Actually, not a new document, just a new page. We are going to add lists and spreadsheets because I added geometry again. We need to make a list. Now, as I've said many times, anytime you make a list, I highly, highly recommend labeling that list because it makes it a lot easier to work with. So, since this data has to do with books, I'm just going to call the list BOOKS. Books. And then you just type in all the numbers that are in the data set. So 20, 36, 52, 56, 24, 16, 40, 4, and 28. We ended up with 9 values, which is good because that's what the problem says. A lot of statistics problems with data sets will just tell you how many points there are. So you want to make sure that matches. And it doesn't hurt to go back through your list and make sure you got all the numbers right because mistakes happen. You might have just typed something in wrong. If we're going to make a box plot, we need to find information about this data. So if we want to figure out those calculations, since there's only one list, we go to the top, we hit Menu for statistics, 1 for stat calculations, and 1 for one variable statistics. Again, the way to remember that, 1 set of data, 1 list, 1 variable. Don't need to change anything here. Don't need to change anything here. This is the easy one. So for a box plot, there are 5 numbers that we need. I'm going to move this aside for a second. Those 5 numbers are the minimum, Q1, or the first quartile, the median, Q3, or the third quartile, and the maximum. And conveniently, if we scroll down, they're all right here. They're all right next to each other. So we just need to copy those numbers down. So we've got 4, 18, 28, 46, and 56. Now, if you forget how a box plot is supposed to look, you can do that on the calculator too. You don't have to, but we're going to do that after we construct this ourselves. So we can see that this does not go up by 1. 0 here and 20 here. If we try to split that up the best we can see that this is going up by 4s. So it definitely does not hurt to label your number line, just so you don't get confused. It's very easy to, mess up when your number line doesn't go up by an easier amount. This is the type of question where I recommend doing it in pencil because you're allowed. For diagrams and graphs and things like that, you can use pencil. So we're going to do that here because if we make a mistake, we want to be able to erase that. First value we plot is our minimum, 4. That's going to go right here. Q1 is 18, which is going to be halfway between 16 and 20. Median is 28. That's going to go right here. Q3, that's 46. That's going to go right between 44 and 48. And our maximum is 56. So It's going to go right here. Once you've got all those points in the places they should be, you take the outer ones, the minimum to Q1 and the maximum to Q3, and you connect those. And then, just like the name suggests, we're going to draw a box from here to here and one line down the middle. Could have been a little better, but there we go. And that's actually it. That's our box plot. Now, in the event that you forget what a box plot looks like, from here, if we make another new page, if we add data and statistics, if we hit 5, right now it doesn't look like anything, but if we take our cursor and we click here and we choose books, it's going to give us a dot plot at first, but if you hit menu, go to plot type, which is just choice 1, you can change that to a box plot, and it'll give you the shape. You can even scroll onto it. We've got our minimum for Q1 18, median 28, Q3 46, and 56 as our maximum. So this gives you an idea of what your box plot's supposed to look like, even if you don't totally remember how to make one. So don't be afraid to use that. It's a good tool. Having a visual for things can make a big difference sometimes. All right, as usual, I'm going to give a couple seconds if anyone has any questions about this one. If not, we will move on to the next question. Okay. In that case, we are going to proceed on to question 29. All right. Given a equals x plus 5 and b equals x squared minus 18, express a squared plus b in standard form. Now, standard form, that has to do with quadratics, and this is another thing that is given to you on the reference table, on the reference sheet. Honestly, before you even start the Regents exam, you should probably take a minute to just look at that reference sheet and see what's given to you, because standard form, you might not have thought about that to begin with, but if you see it there, you might know what you have to do. Standard form of a quadratic is just ax squared plus bx plus c. So we know that whatever our answer ends up looking like, or rather whatever it ends up being, we want it to look like this. So let's see what we can do. We need to start with a squared. We know what a is, so that's just going to be, we're going to put it in parentheses, x plus 5 squared. Okay, plus b, this is b, x squared minus 18, so plus x squared minus 18. Remember, in general, when you plug things in, put them in parentheses. Now right here, x plus 5 squared, something squared is just the same as it multiplying by itself. So this is just x plus 5 times x plus 5. And the second part, technically an invisible 1 in front of here, which we can distribute, which just gives us exactly what we had. Plus x squared minus 18. Now these binomials that we're multiplying together here, we are going to use the FOIL method. I know a few of you the other day said to remind you about FOIL before you walk into the Regents. I will do my best to do that tomorrow morning. But FOIL, first, outer, inner, and last. Whenever you have two binomials multiplied together like that, that's how you multiply them. So we're going to start with the first terms. X times x, that's x squared. Should probably write equals here. X times 5, there's our outer. That's plus 5x. Our inner, 5 times x. That's another 5x. And our last, 5 times 5. is 25. And then we still have plus x squared minus 18. At this stage, we just have to combine like terms. So we can identify x squared and x squared are like terms. X squared plus x squared gives us 2x squared. Our x terms, we just have 5x and 5x, which 5 plus 5 is 10, so we get plus 10x. And 25 minus 18, so use a triangle. 25 minus 18 is 7. So our final answer, we get 2x squared plus 10x plus 7, and we can leave that as our final answer because that is in standard form. Ax squared plus bx plus c. Our a is 2, our b is 10, our c is 7. And we're done. Once again, I will give some time to ask questions on that, but if there are none, then we will just get right back to it. Okay, we're going to move on to question 30. The two relations below, or the two relations shown below, are not functions. Love it when the Regents gives us answers. So we've got a graph to represent our first relation, and we have a set of points to represent our second relation. Our goal is to explain how you could change each relation so that they each become a function. Now, the important thing to remember here is what makes a function a function. There's really only one rule that a function needs to follow. No repeating inputs. Now, when we're dealing with graphs and with sets of points, the inputs are going to be our x values. So let's take a look at our graph here. Let's see how we know this isn't a function. Well, right here, there's a point here, and then there's a point right above it. Because of that, we probably haven't heard this term in a while. It fails the vertical line test. That's how we know this isn't a function. So we just need to think about what we need to change so that that is a function. So we'll just label these separately. For relation 1, what we could do is turn one of these points into an open circle. If we do that, this won't fail the vertical line test anymore. So I'm going to take this point right here, change the points, and that point right there, it is 4 to the right and it is 20 up. So the coordinates of that are going to be 4, 20. And all we need to do is change that to an open circle. And if we were to do that, this would be a function because it wouldn't fail the vertical line test anymore. For relation 2, we need to figure out why this one fails the vertical line test. Well, not the vertical line test. Why it's not a function, my bad. Well, if we look at our inputs, -5, -4, -2, -1, and -4, we have a repeating input, -4. So we could either change one of those -4s to a different number, or if we want to take the nuclear option, just say remove the point. Let's just remove -4, 4. If that point isn't in there anymore, then this is a function. We don't have any repeating inputs. So by removing the point, it's now a function. And that's it for number 30. Once again, I'll give everybody a couple seconds to get that down, ask any questions you might have, and then we will move on to question 31. All right. Seems like we're okay. So let's keep moving. We've only got 7 questions left. We're almost there. All right. Factor 2x squared plus 16x minus 18 completely. So to factor something completely, that pretty much just means breaking it down into the simplest pieces possible. Anything that can't really be broken down anymore. When you're factoring, the first thing you want to find is the GCF, the greatest common factor. If we look at our numbers and our variables here, all of the terms don't have an x, so we can't take out any variables, but 2, 16, and negative 18 do have a common factor, and that is 2. So we can factor out a 2. We can rewrite this as 2 times, and then we just divide all the coefficients by 2. 2 divided by 2 is 1, which we don't have to write, so that's just x squared. 16x divided by 2 is 8x. And negative 18 divided by 2 is negative 9. Oh, there we go. I fixed it. So we now have 2 times x squared plus 8x minus 9. Now, if you were to leave your answer as that, you would not get full credit because we have to factor completely. This trinomial here is in standard form, and hopefully this looks a little bit familiar because we can continue factoring this. This should look like something 2 times 2 sets of parentheses, both of which start with x. Now there's a trick. We can use our calculators to kind of figure out the answer but not figure out the answer. We can figure something out that tells us the answer. So what we're going to do, we're going to go right back into our regular calculator. I'm just going to make a new one at this point. And as usual, we hit menu. We go to 3 for algebra. But this time, we're going to use the polynomial tools. That's what this thing is. This is a polynomial. So that's the tool we want to use. Just choose the first one. You don't have to change anything here. And this is where we remember our A, B, and C. A, in this case, since there's no number in front of x squared, is just 1. B is 8. We hit tab to go down. Tab again. C is negative 9. Just hit enter a few times. It will give you these solutions. But these solutions, which I'll just write right here, negative 9 and 1, we actually want to swap those. We want to flip the signs, kind of like we did earlier. This would give us 2 factors of x plus 9 and x minus 1. So since those are our factors, that lines up perfectly with what we want here. So 2 times x plus 9 times x minus 1. And now we have factored it completely. There's nothing else we can do here. It's broken down into the simplest form possible, so we're done. We'll give a second again for any questions that anyone might have, and then we'll go on to question 32. All right, we are going to continue to question 32. Solve 3d squared minus 8d plus 3 equals 0 algebraically for all values of d rounding to the nearest tenth. Just a few things to identify before we really get into the problem. Whenever something says algebraically, that basically means show work, don't use a graph. That means they want you to use algebra. They want you to show the process of breaking this down and finding the solutions. Rounding the answers to the nearest tenth, remember the tenths place, if we have something like 0.1, is just the first decimal place. So whatever our answers are should only have one decimal point. Now this type of equation, this is a very common type of problem, and honestly I hope you guys get one of these on tomorrow's Regents, because we can use my favorite formula in the entire world, the quadratic formula, which, as I've mentioned, is given to you on your reference sheet. So we're going to go ahead and we're going to write that down. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now you might be wondering, but there's no x in this problem. We're using d as our variable, which actually changes nothing. We just replace the x with d and rewrite the formula. It's going to work the exact same way, even if the variable that we're using is not the same. That letter doesn't actually mean anything. It's just a stand-in for something we don't know. So if we're doing the quadratic formula, that means we need to identify a, b, and c. Let's do that. If we look at our equation, a is going to be 3, b is negative 8, and c is positive 3 again. So we just plug it into our formula. D equals negative b, that means we're going to write negative, we use parentheses because we're safe, negative 8, plus or minus the square root of, we have b squared, so we're going to do negative 8 squared, minus 4. Remember that 4 is just part of the formula. A is 3. C is also 3. All over 2 times 3. Now, here's the nice thing about this problem. We don't need precise answers. If it wanted the exact answer, we would have to simplify all this and use our radical simplification techniques, which can take some time. It's doable, but takes up time. Since we just have to round to the nearest tenth, we can just plug a lot of this into the calculator and just round what we get. The only thing here you can't plug into the calculator is that plus or minus. But we can just split this up into 2, because that plus or minus just means do it once with addition, do it once with a minus, or with subtraction. So our first solution, we just rewrite the whole thing, but instead of the plus or minus, we write it with a plus. And for the second one, we rewrite the entire thing, but with a minus. That's all plus or minus means. So now we just take both of those, plug them into the calculator, and whatever they are rounded to the nearest tenth, those are going to be our solutions. So let's go ahead and do that. I'm going to make a fraction, control, divide. So on top we have negative 8 plus the square root. And again, just type exactly what you have on the paper. And on the bottom, 2 times 3. We hit enter. We get this decimal as our answer. But since we are just rounding to the nearest tenth, all we need to do is look at the first decimal place. So 2.2 is going to be our first answer. For the second one, you don't have to retype the whole thing. You just go up twice, hit enter, and just scroll back and change that plus to a minus. And we get 0.45. 0.45. I think that's right. Yep, 0.45. We round that to the nearest tenth. My bad, I got confused for a second. Since we're going to this place, but the next digit is a 5, we have to round up. So that actually becomes 0.5. When that digit is a 5, it's very easy to make a rounding error. But remember, if it's 5 or higher, you round up to the next in the next position. So 0.4514 blah 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 is 0.5 when rounded to the nearest tenth. And there we go. That's 32. So quadratic formula, if it says to round it, you can do most of the hard part in the calculator. Don't stress about simplifying any of this. You can. It's just not necessary. So break it down, put it into the formula, and split it into 2, plus and minus. Give a couple seconds for writing this down and asking any questions. And we'll move on. Okay. We are going to proceed on to question 33. Now we are officially in part 3 of the Regents exam. So each of these questions are going to be worth 4 points, or 4 credits, you could say. Every question we've answered at this point has been 2 points on the test out of 86. Each of these is now worth 4. So there's more to them, but they are worth more points. So, as usual, do everything in pen, except if it's a graph. In that case, you can and probably should do it in pencil. So our first task, graph f of x equals the absolute value of x plus 1, and g of x equals negative x squared plus 6x plus 1 on the set of axes below. You can probably guess where I'm going with this already before I even say it. We have graphs to make. Let's use the calculator. So we're going to make a new document, add some graphs, and let's just type these in. Our first one, f of x equals the absolute value of x plus 1. Remember, if we want the absolute value, we can hit the book symbol right under delete. And you have all these tabs up here. As long as you're in the first one, which you can always navigate to by you can just press the numbers. So if I press 2 or 3, you want to be on 1. The top thing there is absolute value. So we want absolute value of x, close the parentheses, plus 1. There's our first graph. For our next one, we're just going to hit tab. It gives us another space for a function, negative x squared plus 6x plus 1. So we've got our graphs. But that doesn't help us out a lot because these graphs are on a screen and we need the graphs on the paper. Well, the easiest way to get from one place to another is to use that trace feature again. We're going to hit menu. We're going to hit menu. We're going to hit 5 for trace and 1 for graph trace. And again, this allows us to move right along. Raul, you are not cooked. You can do this. Again, you can pass with just some of the multiple choice, so try your hardest tomorrow. So we want to mark as many of the integer coordinates as possible. We can see that this point that we're on currently, again, it's marked with like the little circle there, is 0, 1. So let's just start with that point. Scary Larry and Miss Comfort here. Good to see you too. Glad you could join in for a little while. Oops. So we're going to trace along this graph and just get to the points where we have integer points. How do you do it in the calculator without breaking it up? When you say, I'm not sure what you mean by breaking it up. If you could explain that question a little more, I'll try to answer. You forgot. I'm not totally sure what you mean by breaking it up. What I can do is I can just show you again, when you make a new graph, if you hit tab, it gives you a chance to put in another function, so you can put more than one function in there at a time. Just going to back out of that. I'm going to go back into our trace. We've got another point here, 3, 4. So we can put that point on here. And since we can see this is a straight line, if we just get another point on the other side, then that'll be enough for us to finish the graph itself. We've got the point -3, 4. Oops. Mr. D can't count. I was still watching 23. I just realized I was behind. Oh, okay. I got you. So once you've got a few points, what I recommend doing is just to follow the pattern and keep putting more. Many as you can fit. We're going to connect the dots. Make sure always draw your arrows on the end and label it. This is f of x equals the absolute value of x plus 1. Now, we're only halfway done with graphing. We want to graph g of x now, which, again, we could do with a similar method with trace, but there is another way. If we hit menu and we go to the table is very useful for graphing as well. Just hit 1 for the split screen table. As long as you're paying attention to which function you're looking at the values for, make sure you're looking at the right one. You can actually just get the points from here. So, for example, we have the point 0, 1. So that's already plotted on the first one. We've got 1, 6, which is going to be 1, 2, 3, 4, 5, 6 up and 1 to the right. We've got 2, 9, which is going to be right here. 3, 10. And then we can see it turn around. We go back down to 9 and 6 and 1. So we found our vertex. And again, you want to draw as many of these points as you can. Once we've got this shape going on, we do our very best to make this a nice, neat parabola by connecting those points. Mine could be a little better here. This is why graphing is good to do in pencil. Better. And again, we are going to label. That is not f of x. That is g of x equals -x squared plus 6x plus 1. So we finished the graphing step. Unfortunately, this is a 4-point question, so that isn't everything we have to do. The next part, based on your graph, determine all values of x for which f of x equals g of x. Well, if we want to figure out where these two functions are equal to each other, we can just look at the graph. So the first point they intersect is right here, and the second point they intersect is right here. So, hold on. I may have... Give me a moment to look back at my graphing here. Oh, okay. No, there's no problems. My graph was just not perfect. They do intersect right here. So right here, we can tell what the x value is. It's right in the middle, which means that x equals 0. And at this point, we are 5 to the right. 1, 2, 3, 4, 5. So x equals 5. And there's our full solution. We have our two graphs. They are both labeled and drawn correctly. And we have our two solutions right here, because that is where they intersect. That's how you can find the solution to one function equaling the other. Once again, these are a slightly longer problem, so they do take longer, but that's okay. There aren't as many of them. I will give you guys a few seconds to write down whatever you need to, and if you've got questions, ask away. Okay. Doesn't seem like anyone has any questions, so we are going to move on to question 34. This was question 33. Here is 34. All right. Jean recorded temperatures over a 24-hour period one day in August in Syracuse, New York. Her results are shown in the table below. So we've got a big table of data. And we want to analyze it. Now, luckily, we don't actually have to plug this into the lists and do all the stats stuff. That's not what we have to do with this problem, which is kind of nice. Our first goal here is to state the entire interval over which the temperature is increasing. So if we want to see if something is increasing, we generally want to look at, as we go left to right, is it going up or is it going down? If it's going left and up, that means it is increasing. So we know that that's going to be from right here to right here. We see that our x-axis, our horizontal axis, is time in hours. So from 6 hours to 12 hours is when it's increasing. And that's exactly what we're going to write. From 6 hours to 12 hours. Next, state the 3-hour interval that has the greatest rate of change in temperature. Well, once again, looking at our increasing interval, there's only 2 3-hour intervals to look at. And we can see that the second one is steeper. That's how you can tell the rate of change. Rate of change is just slope. So since that second interval is steeper than the first one, that's the one we're going for. So that's from 9 to 12 hours. So again, that's exactly what we're going to write. From 9 hours to 12 hours. Finally, we need to state the average rate of change from hour 12 to hour 24. And we need to explain what this means. So we do need to go into detail with this one. So average rate of change, there is a formula for that. y2 minus y1 over x2 minus x1. This might also sometimes be written in terms of different functions. However, or rather in a function, we're just going to use the y2 minus y1 over x2 minus x1. It's the slope formula, but it does the same thing. So, looking at our information, we care about from 12 to 24. Now, it's a little hard to pick our x and our y. How do we know which one is x and y? Well, we look at the graph. The x-axis is time, and the y-axis is temperature. So the temperature values must be y, and the time values must be x. So we follow our formula. y2 minus y1, that's going to be 74 minus 92. Got that there. Divided by 24 minus 12. And if you really feel like doing that manually, be my guest. However, I don't. So we're going to do this in the calculator. I'm going to make a fraction. 74 minus 92 over 24 minus 12. And that gives us negative 3 over 2. So just keep that visible. Negative 3 over 2, and we do need to be specific with units. So that's degrees per hour. Now, that's kind of a weird way to put that, negative 3 over 2 degrees per hour. So what we can do to actually explain this in the context of the problem, and just kind of based on how slopes work in a problem, rates of change, is this just means the temperature falls, or decreases, you could say, by 3 degrees every 2 hours. That negative 3 on top and the 2 on the bottom, 3 degrees, and it's negative, per 2 hours. Temperature falls by 3 degrees every 2 hours. And there we go. There's our explanation. And that's everything for, this was number 34. Let me just make that visible. Once again, I'll give you guys a couple seconds to write that down further, or if you have any questions, give you a chance to ask. I do want to say before we move on, I really do appreciate everyone that decided to tune in. It seems like there's 9 people still in the audience, and you stuck it out. We're almost 3 hours into this, and you're still here, so thank you. And hopefully this makes a difference tomorrow. We are going to go ahead and move on to question 35. There are actually only 3 questions left. We're very close to the end now. All right. Solve the following system of inequalities graphically on the set of axes below. So we've got these 2 inequalities here, and we need to graph them. Now, graphing inequalities can be a huge pain because normally, if we didn't use the calculator for this, we would have to solve both of these inequalities for y, which takes quite a few steps sometimes. It's going to take up a lot of space. It's going to take up a lot of time. And you're more likely to make mistakes in simplifying when you do more steps. So we are going to take advantage of our calculators to the fullest, and we're going to make it graph these for us, and we're going to translate those onto this graph. So let's go ahead and give this a shot. That glare is not great. So we're going to make a new graph. And this time, instead of doing f of x equals something, or f of 7x it is this time, we're going to hit delete, and we're going to go down to relation. That allows us to type in equations and inequalities that aren't solved for a variable. So the first one, 2x plus 3y. We do control equals to get these signs. We need greater than or equal to. Minus 6. Or negative 6, we hit enter, and it gives us this graph. So this just right off the bat gives us an idea of what it's supposed to look like, but we can use that trace feature to find exacts. So we're going to do that. Menu, 5, graph trace, and we can see immediately we've got the point 0, negative 2. I'm going to start by putting that right here. Make that a little better. Let's move around a little bit. Let's see if we can get this intercept over here. Yes, we can. Negative 3, 0. Once you've got 2 points, that's technically all you need because you can continue the pattern. This goes from here to here. It's down 2, right 3. So let's just continue that. Down 2, right 3. And we do that until we run out of room. Go backwards. And there's all our points. Now normally when we graph, once we have all our points, we want to connect them. But since this is an inequality, we need to pay attention. We need to be careful. This inequality has a greater than or equal to in it. Now, regardless of its greater than or less than, if it has the or equal to, this is going to be a solid line. Now, we're going to have to see on the next one, since it has just a less than, that's going to be a dotted line. So let's get this one done, then we can move on to the second inequality. We draw our arrows. And since this is an inequality, we have to shade, but luckily the calculator told us already where we need to shade. It looks like above the graph, so that's what we're going to do. My recommended method of shading is by drawing these perpendicular lines. You don't need to scribble all over the page to shade. You might want to do it in a way where it's a little bit easier to, see. Because we do still have another graph to make. Let's just go ahead and label this so that we don't lose points for that. This is 2x plus 3y greater than or equal to -6. And now we're just going to do the same exact thing for the other one. We can plot it right on top of this one. So this one is x is less than, so control equal, less than 3y plus 6. All right, it's a little weird looking on here. We can see where they overlap. We can also see the area above this one. So we're going to use the trace feature again. Menu, 5, graph trace. And we want to make sure we have the right one selected. Currently, we do not. So we go down, and now we can see we are moving along the correct graph. So let's see if we've got an intercept right here. Looks like we do. 0, -2, we actually have that point already. That's kind of nice. If we go backwards a little bit, we see that we have the point -3, -3. So that's going to go right here. And now we use that pattern to fill in the rest. From this point to this point, it's going up 1, right 3. So let's continue that pattern. Up 1, right 3. And we do that until we do not have any more room. Since this inequality does not have the or equal to underneath the inequality, we have to draw a dotted line. Again, you will be provided with a ruler tomorrow, so don't stress about your lines being straight. You'll be able to do it. I probably should have done it considering I have a ruler right here, but that's fine. Another reason you might want to do your graphs in pencil, if you accidentally make a line solid and then decide that you want to make it dotted, very hard to fix that if it's in pen. So I definitely recommend doing your graphs in pencil. For this one, we just look at the calculator again. We can see that we are shaded above this line. So we do the same thing. We're going to draw our perpendicular lines. And we're going to see that they overlap with the other shaded area as we do this. It's a little ugly looking, but it does get the job done. We're going to write the inequality over here. We're going to label it. And finally, we are going to label the solution set, S. The solution set just being where do the two inequalities overlap? And we can see it's this region here where we have two sets of lines going back and forth. So literally, draw it as big and visible as possible. S. S for solution. Doesn't need to be super artistic. As long as there is just an S in that region that is visible, you'll be fine. And that is our graphed inequality. Unfortunately, we do still have more, but we're going to get through it. Is the point 4, -2 in the solution set? Well, Let's find out. 4, negative 2, that's 4 to the right, and 2 down. We'll even label that so that it's easier to justify. And we can see that while it is a solution to one of them, it is not a solution to the system because it doesn't lie in the solution set. So we're going to explain it that way. No, you could also just write no here, because we're going to be specific. When graphed, or rather, when plotted, the point does not lie on the graph. Now, I just made a Regents mistake. Not a math mistake, but a Regents mistake. And I'm glad that this happened, actually, because I can point it out to all of you. I just wrote an answer in pencil. That wasn't a graph. If I were to leave this, if this was my exam and I handed this in with that correct answer written in pencil, we would not get credit for that. So we're just going to go over and trace it with pen. When you take your test tomorrow, you will be reminded to look back at your test and make sure things are in pen. Because again, if they are not, they literally can't grade your answers. So you don't want that. There we go. That's an acceptable response. All right. So for our inequality graphing problem, that is it now. I will give everyone a moment to ask any questions you might have, and then we'll move on to 36, and we'll only have 2 questions left. All right, doesn't seem like anyone has any questions for this one. So, on to 36. Susanna collected information about a group of ponies and horses. She made a table showing the height, measured in hands, and the weight, measured in pounds, of each pony and horse. So we've got a table of data here. Here's the height. Here's the weight. We're labeled one of them as X, one of them as Y. That should be a hint to what we're going to do with this. Our first task, write the linear regression equation for this set of data. Round all values to the nearest hundredth. That just gave us a lot of information. Linear regression is a statistics term, which means we're going to be putting all this data into a list in our calculator and doing some stats calculations. So let's go ahead and do that. So we are going to make a new lists and spreadsheet. That's option 4 when you make a new one. We are going to label our 2 lists. Keep it simple. If there's 2, just do X. Oh, I see what happened there. We assigned X to a number earlier in this document. So if that happens, you can just go home, make a new document, and then you don't need to worry about that anymore. Just make sure you don't delete anything you were previously working on. Now we can call that X, and we can call that Y. We're just going to go ahead and put in our values from the table. So it's just 11 through 17. So there should be 7 points of data. And then the second one, 264. 638, 700, 850, 1,000, 1,230, and 1,495. Once you've got all these values, you want to go to the top right of your lists, right here at the top, hit menu. We're going to go down to statistics as usual. 1 for stat calculations. And since we're looking for a linear regression equation, we're going to choose choice 3, linear regression. Yes, I know that there is a second one. We want to stick with choice 3 because it's more familiar. For our X list and our Y list, change your X list to Real Creative X and our Y list to Y. Hit enter, and it should give you all of this. So we want to remember that when we write equations, generally, they're going to be in the form y equals mx plus b. That is another equation that is given to you on your reference table. So I can't, stress this enough. Use your reference table. Look at it. So we just need to figure out m and b. And if we look, those are given to us, m and b. So the problem wants these rounded to the nearest hundredth. So looking at m, 184.892 to the nearest hundredth, that would just be 184.89. And b, we actually can't even see the whole number, so if we scroll over it, we can see all of it here. Negative 1,706.071. So nearest hundredth, it's 0.7. So negative 1706.07. And once you've got those values, you just write the equation. Y equals m is 184.89. I realize my 9 looks like a 4. X minus, you could also write plus negative, that's fine too, 1,706.07. And that's your regression equation. The next part is even easier. State the correlation coefficient for the linear regression. Round your answer to the nearest hundredth. The correlation coefficient, that's R. So we just need R equals, you can look at our data, scroll down, we don't want R squared, we want R, 0.985 rounded to the nearest hundredth would be 0.99. And finally, explain what the correlation coefficient indicates about the linear fit of the data in the context of the problem. This is a very easy way to lose points if you don't read it clearly. In the context of the problem. That means we can't just say, like, strong positive. That's good to include because it is a strong positive correlation, but we need to actually say, what does it mean about our data? Well, if we look at it, as height increases, so does the weight. And that's just an observation that we can make. As the height increases, the weight also increases. So we can write that. As the height, this is about horses and ponies, as the height of a horse or pony, we're going to be real specific, increases, so does its weight. Which, that makes sense. As an animal is larger, it's probably going to weigh more. And there we go. We've got our regression equation. We've got our correlation coefficient. And we have a conclusion that we were able to draw based on that data, or rather those calculations and the data that was given to us. I'll leave that up for a second if anybody needs to get that down or ask any questions. Okay. In that case, we are going to move on to question 37, which is the final question on this Regents exam. Now, if you will recall, the other day, or last week, whenever it was, When we were going over review problems, I said that on every Regents in the last couple years, the Part 4 question was a system of equations problem. This is our Part 4 question. It's worth 6 points. And would you look at that? It's a system of equations problem. I will genuinely be shocked if the question on your Regents tomorrow for Part 4, question 37, isn't a system of equations. I will actually be surprised. So if this is something you're good with, try to just get this one done. They're very similar problems to each other. You just have to read them very carefully. So let's give this a shot. Dana went shopping for plants to put in her garden. She bought 3 roses and 2 daisies for $31.88. Later that day, she went back and bought 2 roses and 1 daisy for $18.92. If R represents the cost of 1 rose and D represents the cost of 1 daisy, write a system of equations that models this situation. So they give us a lot here. This is lined up very nicely for us. They give us the numbers and the quantities and the totals right next to each other. So let's just translate this sentence and the next one into an equation. She bought 3 roses, so 3 roses is going to be 3R, and that's just plus 2 daisies, so 2D, for $31.88, so equals $31.88. And that's our first equation right there. 3R plus 2D equals 31.88. We do the same thing with the second one. 2 roses and 1 daisy for $18.92. That one's even more clearly laid out. 2R plus 1D. You can also just write D. You don't need the 1 there. Equals $18.92. So let's write that here. 2R plus 1D equals $18.92. That's 2 points right there. Again, this is a 6-point question. You get those done just by writing the equations. You've already got some points on that question. That first part is very doable, even if the rest of the question gets a little bit more challenging, which it does, but we're going to get through it anyway. Next step, use your system of equations to algebraically determine both the cost of 1 rose and the cost of 1 daisy. This is another case where it will benefit you to find the answer before you do the work. Your calculator can solve a system of equations for you. Let's see how we can do that. We're going to go into a calculator. And to solve a system of equations, we start by hitting Menu, shocker. We go to Algebra. And we're trying to solve a system of linear equations, so that's what we're going to choose. There are 2 equations, and here's where we can change things. Our variables, x and y, we're not using x and y. We're using R, comma, D, roses and daisies. Now we write the equations exactly as we wrote them. 3R plus 2D equals 31.88. We go down. Second one is 2R plus, I'm just going to say D because that's the same thing, equals 18.92. And it gives us these 2 answers here, 5.96 and 7. And honestly, just write those. R equals 5.96 and D equals 7. Now that we've got the answers, before we even did any work, once we show the work, even if we make some mistakes, we've got the answers there. We know what we're working towards, and we can probably earn some credit for that too. Now, for solving this particular system of equations, my recommended method is going to be the elimination method. So what we're going to do that is we're going to take this second equation here, and we're going to multiply it by -2. Now what that'll do is that's going to line it up so that the variable D is going to cancel out and we can solve for R. So I'm going to write -2 times times 2r plus 1d equals 1892. We're basically just distributing that negative 2. So we end up with negative 4r minus 2d equals, I need the calculator for this one, negative 2 times 1892, negative 37.84. What we can now do is add that equation to the first one. So 3r plus 2d equals 3188. We add the whole thing, and we just go term by term. Negative 4r plus 3r gives us negative 1r. Negative 2d plus 2d, that's our elimination step. Those cancel out, so we don't even need them, equals negative 37.84 plus 3188. We're going to use the calculator for that one for sure. You can actually just do plus 3188. And we get negative 5.96. Only step we have left to solve this. Divide by negative 1. And we get r equals, if you divide by negative 1, it's the same thing as multiplying by negative 1. Negative times a negative, or negative divided by a negative, they cancel out. So we get r equals 5.96. But we don't just want r. We also need d for daisies. So we take the original equation. I would recommend actually using the second one because it's just 1d. So we get 2, and instead of r, we're going to do 5.96 plus, remember 1d is the same thing as just d, so let's just replace that, equals 18.92. We simplify this, 2 times 5.96, I'm going to throw that in the calculator. 11.92 plus d equals 1892. And finally, we subtract 11.92 from both sides. And we get d equals 7. So the cost of a rose is $5.96. The cost of a daisy is 7. And again, don't bother boxing in your answers, just leave them there. And those match up with the solutions we got from the calculator, so we know we're right. Now, the part 4 question, it's long. We've already done 2 pretty long parts of this problem, and yet we still have more to do. But this last part is going to be our last. So we're going to flip the page to get to the second part of this problem. If Dana had waited until the plants were on sale, she would have paid $4.50 for each rose and $6.50 for each daisy. Determine the total amount of money she would have saved by buying all of her flowers during the sale. Well, that means we first have to figure out how much money she spent in the first place. So we got to look back at our first page then. We never did calculate how much money she spent in total. However, we do know she spent $31.88 and she spent $18.92. So I'll try to make both of these visible. If we do $31.88 plus $18.92, that's going to give us the total. So I'm going to throw that into the calculator real quick. 3188 plus 1892 gives us 50.8. Now remember, we are dealing with money here, so you want to keep that second decimal place. It seems weird to just add a 0, but it is important when we're talking about money. Now, it says she would have paid $4.50 for each rose and $6.50 for each daisy. That means we also need to figure out how many total roses and daisies she bought. Well, 3 roses and 2 roses gives us 5 roses. And the daisies, 2 daisies plus 1 daisy, gives us 3 daisies. So with these new prices that were given to us, $4.50 for each rose, $6.50 for each daisy, we just have to do $4.50 times 5 plus $6.50 times 3 and this is probably going to be it's the second to last time we're going to use the calculator tonight. 450 times 5 plus 650 times 3 gives us 42. So $42 is how much she would have spent. So if we need to figure out how much she would have saved, we just have to do $50.80 minus $42. $50.80 minus 42 gives us 8.8, or as a dollar amount, we include that second decimal. So she would have saved $8.80. And with that, we're done. We have survived an entire Regents exam. So it looks like we've spent just under 3 hours. We started at 5, so it's been 2 hours and 52 minutes, minus the little break in the middle there. So we made pretty good time. This is a pretty reasonable pace to go through the Regents. If you needed to go longer, you will still have time. Like I said, we took a break and it took us a little while to get started. And you're also not going to have to explain every single question, so you can move a little faster. At this stage, I want to give the opportunity where if anyone has any questions about any of the problems that were on this Regents exam, now would be a time where we could go back to them, we can revisit them, and just see if there's anything. W stream. Thank you very much. I appreciate that. Again, I really do appreciate everybody coming out tonight and watching this. It's just for you guys. Test in the morning. I know it's early, 8 a.m. Kind of sucks, but you can do it. Try to get there on time, get some good sleep tonight, and try to eat breakfast. It's good to keep your brain active. I'll hang around for another minute or two to see if there's any further questions. Okay. Doesn't seem like there are any questions, so what I'll do, I will keep the stream running for a couple minutes. I'm going to turn off the camera and the audio. However, the chat will still be active, so if you have any questions, you can ask them there. But if nobody asks any questions in the next 5 or so minutes, thanks for coming. I'll see most of you tomorrow in the morning, and that's it. Have a good night, everybody.